Good morning, everybody. Welcome to Water Project Europe 2025. Today is the 25th of June, 2025. We are hosting a new edition of Water Project Europe. I'm Andrea Rubini. I'm the Director of Operations of Water Europe, European Water Technology Platform, which advocates for the achievement of water smart society and economy. And today we host an important Water Project Europe, which aims at exploring the opportunities given by three sister projects working on circularity in industrial water. As you know, also because of the recent published water resilience strategy of the European Commission, water it is nowadays a big challenge for each and every sector because of scarcity, because of extreme events, because of connection into the climate change problems, because of increase of the demand. Don't want to mention the figures now, but I mean the situation is absolutely pressing and extremely concerning. Also in terms of forecasting of what will be the capacity of a system to meet the demand of water, both from the industrial side, in agriculture, and the households and the urban areas. So having said that, water represent in the industrial framework an essential component. I mean, water is the most used diluent in the industrial processes. Water is needed for cooling processes, for many other applications in the industrial environment. So water represents, I mean, one key enabler, also as reported in the water resilience strategy for the industry, and its scarcity or difficulty in accessing of adequate sources of water might represent a serious bottleneck for our industries to remain competitive in even in the short run. Today we have three projects. We have Resurgence, of which Water Europe is proudly partner, Cornerstone, and Revolution. And these three projects, looking from different angles to water circular achievement, circularity achievement, and sustainability in the long run, belong to the same call for proposal, which comes from the public-private partnership with the European Commission and Aspire Processes for Planet. Aspire generated in the past years, also in Horizon 2020, several important, outstanding projects. I can mention highways, I can mention Aquaspice, which really provided bright examples of solutions for water industrial management. Having said that, I would like to highlight, I mean, the matter that our industry in Europe has the need for keeping its capacity of being competitive, not only from the point of view of technology, but also from the point of view of governance of the resources. Water represents one of the resources which is close, I mean, to be crossed in terms of planetary boundaries, and this is quite, I mean, important alarm that rings in the places where water is considered as, I mean, a main concern for sustainable development of our Europe, our societies. We have three projects, I said, Resurgence, Cornerstone, and Revolution, and we are honored, I mean, to have the coordinators today presenting the project. This is the first clustering initiative between the three projects, and many others will come, either online and in presence. And this event, this kind of event, this Water Project Europe, this clustering event, aims at having the project working together, establishing a dialogue, a constructive dialogue, and allowing them, I mean, to see about the achievements of the others and to cooperate and to increase the synergies in terms of achievement, in terms of dissemination, in terms of outreach of users of solutions offered by the projects. I don't want him to speak more than I did. Maybe that I really spoke too much this morning. So, the time has come to give the floor, to the real actor of this Water Project Europe. And we have a keynote from Matteo Pasteur, who is from Veolia. And he represents the water sector in the SPIRE process for public-private partnership. And after that, we have the presentation by the three projects, starting from Revolution with the project coordinator Eric Santos from Setaqua. Then we have Cornerstone, will be presented by Sienna Chris Jensen from the Aalborg University. And then Resurgence, which will be presented by Xue Yang, project leader of the project. And after that, we have an interesting panel between the speakers of today, and to check and start, working on the potential synergies and the insights coming from the discussion of today. So I'm happy to give the floor to Matteo Pasteur for the keynote. Thank you so much, Matteo.
Thank you, Andrea, for the kind introduction. I will share my screen with the presentation. We can start. 1 second. So I believe that you can see the presentation. So, well, my name is Matteo Pasteur. I am a strategy manager at Setaqua in Veolia Group. I'm, as Andrea mentioned, water sector representative at the SPIRE board of director. For today, well, I will give a short presentation about SPIRE, the processes for partnership and its strategic agenda, and how it is aligned with the EU strategy and the new water resilience strategy. For those who don't know about SPIRE, SPIRE is a European association, a private European association that represents 10 process industry sectors, from cement, ceramics, chemical, steel, mineral, metals, pulp and paper, and also the water sector. And SPIRE represents around 20% of the European manufacturing sector in employment and turnover, and also represents more than 170 industrial and research stakeholders from more than 20 countries in Europe. SPIRE is committed to manage and implement the processes for planned co-program partnership in collaboration with the European Commission in the context of Cluster 4 of the Horizon Europe funding program, with a amount signed for a value of 1.3 billion euros. Now, I would like to give you a short overview of the Strategic Research and Innovation Agenda, what is called as RIA 2050. This strategic agenda was defined in the context of the European Green Deal, and it was defined by SPIRE, all its members, and in collaboration with the European Commission. And at that time, three main challenges were defined for the process industries. The first one, the high impact on climate change. The second one, the linear use of resources. And the third one, the global competitiveness and investment. And to overcome those challenges, three main objectives or ambitions with specific targets were defined within the strategic agenda. The first one is the development and deployment of climate neutral solutions. At the beginning of the partnership, the total emissions by the process industries in Europe were around 750 million tons of CO2 per year, and the target by 2050 is to achieve the net zero emissions, a very, very ambitious target. Then a second ambition or objective were defined, that is closing the energy and feedstock loop through the deployment of sustainable and circular business model. That ambition, of course, is very well related to the objectives of today's projects. And the target defined was to achieve near zero landfilling and near zero water discharge in 2050. And finally, a third ambition, the competitiveness ambition, was defined to achieve a global leadership in climate neutral and circular solutions, with a strong focus on generating the market for all the solutions developed within the partnership. In the strategic agenda are defined the innovations needed to achieve these very ambitious targets and goals. Innovations in terms of resource efficiency, energy, digitalization, and also non-technological aspects. For example, on the resource side, the needs of successful urban industrial symbiosis models to increase efficiency and byproduct valorization. On the energy side, the need of innovation to electrify the industry, to change the energy mix, to deploy carbon capture and utilization, and other innovations. And also, as I say, the digitalization to accelerate all this transition and non-technological aspects, such as the regional industry society collaboration that is needed to successfully deploy all these solutions. In total, in this RIA document, there are more than 36 detailed innovation programs, and I don't want to go into the detail of all of them today. I just wanted to give a short introduction of the main ideas. But I want to add that this SRIA document goes from the development to the implementation at full scale at TRL 9. So it goes beyond the TRL 7. In this sense, the Spire members have indicated their intention to invest in what they call first-of-a-kind plants, or how we call it in the Spire community, marvels. And that shows a strong commitment to deploy the solutions, to industrialize the solutions, and to confirm a market pool for the innovations developed within the projects. To continue with the presentation of the strategic agenda, I want to move for this high-level overview to the specific KPIs that were defined a few years ago. I believe that those KPIs are still very important for today's society, and I want to focus a little bit more in the first 3 KPIs. All of them were defined to be achieved at TRL 7. It means demonstrated within the projects that are developed within the program. The first KPI was to achieve a 100% reduction of total CO2 emissions. The second one, a reduction of 80% of waste and secondary raw materials. And the third one, which is the main KPI of today's project in the webinar, is to achieve a 90% reuse of wastewater in the industries. And the KPI that, as I say, is the main KPI for today's project is very well aligned with the new water resilience strategy that was released a few days ago. I want to go a little bit deeper in that point. As Andrea mentioned at the beginning, the context today is forcing the industry to be more efficiency in the use of water and also in the use of alternative water resources. And that represents a big challenge for the industry and the water sector, but also a big opportunity for new solutions to be developed. In the last 3-4 years, we have suffered more droughts. Droughts are increasing in frequency and intensity. I live in Spain, in Barcelona, and in 2022-2023, we suffered a long drought period, and the industries had to reduce their consumption by 25%. That was said during the emergency period. So that reduction in the water consumption, of course, has a strong impact in the economic performance of the industry and in the competitiveness of the industry. I want to mention that in the water resilience strategy is mentioned the report named European Climate Risk Assessment that estimates that the drought and heat events in 2022 causes economic losses of more than 40 billion euros, with the main losses in Spain, Italy, and France, which shows the strong impact of water scarcity in the European economy. And that increases the need of enhancing the water efficiency of the industry and also to reduce the dependency on freshwater resources, to guarantee the production in the industry and to guarantee the competitiveness of the European industry for the coming years. And I think that is a key message for today's webinar, that the industry depends on the water supply, and to maintain production, economic performance, and competitiveness, we need to be water efficiency in the processes that we have in the industry. I added this figure at the bottom of the slide. That is the water efficiency first principle that is defined very well in the water resilience strategy. And it says that first of all, we need to reduce consumption, then to develop measures to increase efficiency, followed by the reduce of water, and finally by the expansion of the water supply. And that principle is very well aligned with the objectives that were established in the Processes for Planet Strategic Agenda. In the Processes for Planet Strategic Agenda was defined that a main objective to develop new sustainable processes and products with an optimal use of resources, also following the principle of sustainable by design. And then it was defined as a main KPI, as you saw before, the reuse of water, which is one of the main objectives of today's webinar. And also, I want to add that on top of that, Europe has a need of raw materials, critical and strategic raw materials, and also we have ambitious goals in renewable energy production. And the wastewater, industrial wastewater, can be a great resource to achieve also those objectives, not just water, also energy and valuable raw materials. And that reinforces the whole message that there is a need of technology, research, and innovation to turn wastewater into a valuable resource that reduce the dependency on fresh water, increasing of core water efficiency, that increases renewable energy production and the production of valuable solids and raw materials, and also that reduces the environmental impact, removing hazardous substances that can be present in the wastewater. To finalize this short presentation, I want just to remark 3 main key takeaways. The first one is that the industry faces challenges, but also opportunities in the context of climate change and new regulations, and also in the context of the new water resilience strategy. And that research and innovation with the water sector are key to overcome these upcoming challenges. And now we foresee a big opportunity to develop new solutions, new processes that can help the industry to be sustainable and to be competitive in the coming years. And finally, a third key takeaway is that probably, as I said before, the next first-of-a-kind plant or the next marvel may come from the results of the Resurgence, Cornerstone, and Revolution projects. So I wanted to close with this happy message and a hope message. So thank you very much for your attention. And now I will give the floor to Andrea to continue with the presentations. Thank you.
Thank you so much, Matteo. I think the message was crystal clear. I mean, demand of water, let's say, increases, but shouldn't. So, I mean, that's in a way the other way around. I mean, industry, not only industry, needs, I mean, to be more efficient, and this can be achieved by several kind of actions, to correct the processes and to make more and more efficient. And also, I would add also working in achieving what are better capacity of cooperating and collaborating between industries through industrial symbiosis approach, which it is starting being much more popular also in terms of urban industrial symbiosis in Europe. And there are several examples also from previous projects, do not belong, I mean, to this call or to Process for Planet or Aspire, but we have, I mean, examples of that. I mean, industrial symbiosis or urban industrial symbiosis is possible with success and can be continued after the projects phase out. Now it's time, I mean, to give the floor to the project. I mean that we have, I mean, now the 3 projects coming up, exploring, giving the opportunity to the audience and to the other projects, I mean, to explore their features. And we'll start with Cornerstone. sorry, with revolution. We start with revolution. Revolution under the umbrella of reuse, resource, and recovery. And I'm happy, to give the floor to Eric Santos, which is the coordinator of the project. Thank you so much, Eric, for being with us today. Please, take the floor.
Thank you very much, Andrea. Can you see the screen?
Yes, in full.
Okay. So thank you, Andrea, for the presentation, and thank you, WaterEurope, for inviting us to this webinar. I'm Eric Santos, and I'm the coordinator of the Revolution project, and an ambitious project for mainly maximizing the process water reuse and the recovery of other resources as well from the industrial processes in a smart, circular, and integrated solution. The Revolution project is coordinated by CETACUA, and just to give a brief overview of who is CETACUA, CETACUA is actually a network of water technology centers that are based on a unique public and private collaboration model. We combine, basically in CETACUA, we combine scientific expertise, industrial know-how, and territorial understanding to offer R&D solutions, and that make the entire water cycle more sustainable and efficient. Our work is driven by a deep understanding of the local needs, ensuring that our innovations deliver real economic, environmental, and social impact. We are divided in 5 areas of innovation. We have the water resources planning and management, then the production and new resources, where is actually where the Revolution project is framed. And then we also have zero waste and decarbonization, territorial and social sustainability, and finally, the digital services and artificial intelligence application. Now, moving on to the challenges that we are trying to address with this project. We have the water scarcity, as you can see here. This is the typical image in Spain that we've had along this year and the past years as well. And water scarcity is actually a big problem in the south of in southern countries in Europe, especially, where it affects 20% of Europe's territory and also 30% of the population every year. Also, this water scarcity issue is likely to increase in the future due to the climate change. So for that reason, we need to manage our existing water resources efficiently and also respond effectively to the current water challenges. Also in the industry, actually 40% of the water abstraction is caused by the industry needs in Europe in terms of water, and in this sense, the industries tend to use this water in a linear economy model. So eventually discharging this wastewater treated to the receiving bodies. This not only has a high consumption of fresh water, but also it leads to complex effluents to treat and also increasing costs. But with that said, and as actually Matteo said earlier, this leads to improvement opportunities, and that's why we propose these innovation projects to overcome these challenges. So that's why in the one of the ways to approach these challenges by to shifting this linear economy model to a circular economy model, like the zero liquid discharge models. That is what we are pursuing in the project. This not only has many advantages, but also it's still in an immature level with high capital costs, energy consumption, and also technical complexities that need to be overcome before they can be implemented at full scale. So that's why we are building the Revolution project. The Revolution project actually is a project that brings together 20 partners from 9 countries in the European Union. It has a budget of around 11 million euros, and it started in January 2024, and its duration will be of 48 months, so until the end of 2027. It's, well, as mentioned here, it's a project funded by the European Union under the Horizon Europe program. And this is the consortium of the project, in which we have different R&D centers and universities, and also key players in the industrial sectors that we're gonna address in the project. So the key objectives of the Revolution project are to basically design membrane-based wastewater treatment trains, not only for water reuse, but also to recover solutes, and also to recover waste heat from the industrial processes, as well as ensuring a complete removal of hazardous substances in these waters. Then develop novel membrane materials and define optimal integration in terms of materials, functionalization, and configuration of these membrane technologies to maximize process efficiency. Then developed a smart digital tool for decision support, risk management, and process optimization for water reuse, solids, and energy. And finally, demonstrate the Revolution toolbox for industrial sites. The industrial sites that we have in the Revolution project, we have 4 demo sites. First one is the petrochemical, led by Repsol, and will be in the south of Spain, in Puerto Llano. It will target more than 90% water reuse, more than 80% heat recovery from industrial processes, and up to 60% recovery of solids such as caustic soda, chlorhydric acid, and ammonia. Then the second one, which is the bio-based chemical industry, represented by Bloom in Switzerland, it will also target similar KPIs in terms of water, heat, and also here we will target organic fraction recovery to bring back to the process. Then we have the steel industry, represented by Celsa, also in Spain, in the northeast of Spain, with similar target values of water recovery, and also will be recovering caustic soda and ammonia. And finally, the pulp and paper industry, led by Felix Schweller in Germany, that will target similar KPIs as well. Then this project follows a clear methodology. To start with, we will be characterizing the wastewater streams and the waste heat opportunities and necessities in the different industrial effluents. For that, we have already been working on that, and we have identified and characterized 16 industrial wastewater streams from the different 4 demo sites that I was talking earlier. That will serve us to select the most suitable membranes and technologies to be deployed in our systems, and with that, design the pilot plans that will be implemented. Then, of course, we need to develop the innovative membranes for filtration in the treatment trains. So that's why we have different partners focusing on that. And actually, they are developing nanocellulose enabled membranes. That's in the case of BTT. Then Vito will be responsible for the surface functionalization techniques for ceramic membranes. And finally, Fraunhofer, that will be developing advanced membranes and operational regimes for membrane distillation. After that, and well, in the meantime as well, we are developing the digital tools in the project. That means different sort of tools, such as digital twins, machine learning models for process control and optimization, explainable AI for understanding better the knowledge generated during the project, and also a digital process assistant to enable decision making. As I said, all these solutions put together and integrated will be developed, demonstrated in the 4 industrial sites that I mentioned, 2 of them in Spain, 1 in Germany, and the other one in Switzerland. And of course, as all these European funded projects, they need to be communicated and disseminated. So we will be participating in webinars like this one today or other conferences as well to disseminate the results of the project. And finally, we will see how the project and the solutions that are being developed in the Revolution project can be replicated in other industries. So, as I briefly said, the outcomes of the Revolution project are several. First one, to demonstrate sustainable industrial water consumption across different industries and also other ones that are not present in the project. Then enable full circular use of water in process industries. This would achieve not only the reduce of freshwater consumption, but also the efficiency of these processes. Then the support of the techno-economic feasibility of these solutions in order for them to be implemented at full scale. Recover substances and energy from wastewater. I mean, we don't only target with the water stream, but also on other parameters that can be present in water. And finally, we want to contribute to the EU climate neutrality goal that the EU has been set. Just a brief summary of the timeline of the Revolution project. We started in January 2024, and we have since then been characterizing the streams and setting up the baselines for the project, as well as the selection of the membranes and designing the systems. Now, as I'm speaking, we are developing the different technologies and solutions of the project. That means not only the membranes, but also designing the treatment trains, the digital tools. We have been also conducting lab scale tests to see the appropriateness of the membranes, and we will end up in this phase by constructing the pilot plants and installing and commissioning them at the industrial sites. We expect to more or less have all these pilots installed at the industrial sites by mid-2026, which is when we will start operating and demonstrating these solutions, as well as doing the techno-economic, environmental, and social impact assessments of the project solutions. That will bring us to end of 2027. That's when the project will end. Yeah, and that was a summary of the Revolution project. Thank you very much for your attention, and yeah, happy to answer any questions you may have.
Many thanks, Eric. It was a clear presentation of the pathways and the ambitions of the project. I think that there will be questions, during the panel discussion for sure, and how the other projects also will be able to interact and create a synergy with Revolution. Now, we can go ahead. Many thanks for keeping the time, Eric. This was perfect timing. And we go ahead with Cornerstone now, and which is about integrated solutions for water, energy, and solute recovery in industry. I'm happy to give the floor to the project coordinator, to Sina Kiss Jensen from the Aalborg University. Thank you.
Thank you, Andrea. And it's my pleasure to present the Cornerstone project here today on behalf of all the Cornerstone partners. And also thank you to Water Europe for hosting this event. So I will tell about the Cornerstone project, which is combined technologies for water, energy, and solute recovery from industrial process streams. And I hope you can see my screen. Some facts and figures for the Cornerstone project. We are 16 partners from 8 different European countries. We have a project budget around 10.5 million euros. our project is also 48 months, and we also started the 1st of January 24. We focus on 6 different treatment modules that I will tell more about in a moment, and we have 3 different case studies. Here you can see the locations of the different partners, and here the logos of the 16 different partners that we have in the Cornerstone project. And this picture is from our kickoff meeting in January 24. So we are both universities, research organizations, large enterprises, so many different partners that comes together to solve the issues with the industrial water treatment for water recovery, energy recovery, and resource recovery. The Cornerstone project, the overall objective is to achieve long-term circular economy of the European industries via recycling and reusing of the resources within the industrial water and wastewater streams. So we have 4 different components, where component 1 is the different treatment modules that we investigate in the Cornerstone project, where we have 5 different membrane-based technologies. We have nanofiltration, membrane distillation, membrane bioreactor, electrodialysis, and membrane crystallization. And then we also have a heat exchanger technology. And what we will do is that we are now testing these technologies at lab scale for the industrial wastewater. And then we will integrate these different technologies later on in the process. The component 2 in Cornerstone project is related to digitalizations, where we integrate different sensors, and then we use AI to optimize the processes. And then we also do digital twins of 2 of our case studies, where we look at the current processes and do digital twins of those. And then the integrated Cornerstone systems, we will also use digital twins. And component 3 is the system demonstration, where we focus on the steel industry, the pulp and paper industry, and the chemical industry. And component 4, which is the transversal strategies, is we look into sustainability assessment, both the environmental, the economic, and the social assessments. We have an exploitation toolbox, where we also develop decision support tools for the industries. And then, of course, we also have a part of communication and dissemination. So these are the components of the Cornerstone project. We have 5 objectives. So the first objective is related to the standalone technologies that we are developing in lab scale. And then we will integrate these technologies into a process train, and we're testing them on in the industrial for the industrial water streams. Then we will integrate the smart monitoring tools in order to digitize the process and intensify the industrial processes. And here is the integration of the Cornerstone systems as the objective number 3 at the 3 different demonstration sites, like the steel, the pulp and paper, and the chemical industry. And as I mentioned, we will also do the sustainability of the Cornerstone solutions. And the last objective is related to the decision support tools, where we look into the industrial water, energy, and resource stewardship. And our objectives are very aligned with the Aspire goals. where we want to reduce the wastewater for European industries. We will reduce the carbon footprint, and we will aim for zero liquid discharge for the industrial processes. And here more in details on the different treatment modules that we look into. So we look into both energy, water, and solute recovery. And for the energy recovery, we focus on the development of non-clogging heat exchangers for the thermal energy recovery, and then also anaerobic membrane bioreactors for recovering chemical energy. So these are the treatment modules that we investigate for energy recovery. And then on the water recovery, we have nanofiltration, hollow fiber nanofiltration, and then different configurations of membrane distillation. And for solute recovery, we look into bipolar electrodialysis and membrane crystallization. And then, as I mentioned, our aim is to integrate these different technologies so they fit and match the best possibilities for the different industries. And our case studies is related to the chemical industry. We have Covestro, and at Covestro we will focus on the chemical energy and water recovery. For the steel industry, we have HKM, where we'll focus on the energy, water, and acid recovery. So for the energy, I forgot to mention for the chemical energy and water, in Covestro side, we'll focus on the anaerobic membrane bioreactor. And here for the steel industry, for the energy recovery, we'll focus on the non-clogging heat exchanger, nanofiltration, membrane distillation, and potentially also bipolar electrodialysis. And the last case studies is in the pulp and paper industry, where we have Essity as a partner. And here we will focus on energy with non-clogging heat exchanger, water, also nanofiltration and membrane distillation, and acid recovery through electrodialysis. And then we would also like to potentially recover different solutes, where we have a focus on sulfate components right now, using membrane crystallization. So again, the concept is that we will integrate different technologies to be able to recover different resources from the waste streams. And we have also done some mapping of the different industries to see where does our technologies fits the best. And when we finalized this mapping, we started to test the different technologies at lab scale. So again, on the digitalization part, we have the sensors, and we integrate the digital twins. And I think this is very interesting that we both do it for the existing processes, but also for the new process when we integrate the cornerstone systems. And then of course we also have a part on the validation when we have the real data. And this will be done for the steel industry and the pulp and paper industry. And then the decision support tools, like for the transversal strategies, the decision to support tools for circular water stewardship, digital industrial water and resource management, and also resource recovery. So when and how should the industries decide whether they have some potential in recovering water and resources from their water streams? And of course, the sustainability assessment and the communication and dissemination, as I also mentioned before. And here a little bit more on the sustainability assessment and where we are now in the process. So we have defined like a methodological compass and strategy for the LCAs, and we have made some baselines of the different technologies, and that we will soon submit in a deliverable. And then we will combine the prospective assessment with the inventories from the digital twin. So this is also saying that we really collaborate also in the Cornerstone project to help each other with finding and getting the right data. So we will collect the primary data and upscale, and then model the future-oriented scenarios. And then, of course, we'll also do the benchmarking. So for the LCA, it's also to see the wastewater coming in, what is happening when we have the different technologies that we are developing in the Cornerstone system, and how is that impacting the outcome of the processes. So very interesting data that we will obtain. And for the decision support tools, which I also think is really a nice part of the Cornerstone project, what we have done so far is that we have looked at the industrial current state assessment, and we will have a public deliverable very soon, or to disseminate the deliverable. And then a task is also looking into the circular water stewardship, and we have the digital industrial water and resource management and the resource recovery. So we look into many different perspectives of how the industries can take a decision or have some tools to decide how they optimize their processes. Yes, that was actually what I had, but it was a pleasure to present the Cornerstone project, and you can find more information also on the project through this QR code, and you're always welcome to also to contact me. My email is here. Thank you.
Thank you, Sina. Thank you so much. I mean, as I said, this is the first opportunity for having the projects comparing the features, ambitions. So far, I mean, the two presented projects, I mean, are quite ambitious, and I guess I know that also Resurgence is ambition, as I mean, a lot of ambitions, and I think that the three projects across their life, I mean, can really coordinate, I mean, align and support each other in achieving the goals. I was also interested, I mean, in the digital management, digital activities that will be done by the project, particularly in the digital twins, which is nowadays, I mean, the leading one of the leading approach in water management, not only in the industrial one. But we will have time, I mean, to discuss about this during the panel discussion, this and other important, interesting issues. Now, the time has come, I mean, to come to Resurgence, which is, let's say, hosting also this Water Project Europe. And Resurgence it's about really embracing circularity in the water industrial use. So it's my really big pleasure to call Chef A. Young, the project leader of Resurgence, to take the floor and speak about, I mean, the features of this project today for this Water Project Europe.
Okay, thank you. Thank you, Andrea, for the introduction. I'm going to share the presentation. Could you see the screen?
Sure. Yes.
Yeah, okay. So, hi everyone, I'm Shufei. I'm here on behalf of Resurgence Project. Firstly, a big thanks to our dissemination responsible in the project Water Europe for organizing this clustering event, which gives us an opportunity to share our perspectives on industrial water circularity with sister projects. I will give you an overview of our project Resurgence, share our vision for transforming industrial wastewater into valuable resources, and the technologies we are developing along with the case studies. Resurgence, like the other two sister projects, is a Horizon Europe funded project running for 48 months from December 2023 to November 2027, with a budget around the 9.2 million euros. The project brings together 18 partners and 2 affiliated entities and is coordinated by us, CEDIM, based in Spain. We are a technological center in the north of Spain. And our consortium includes universities, research centers, companies, and large industrial partners from across Europe, as well as a chemical industry partner from Turkey and a university from Pakistan. Our main objective is to help the transformation of European process industries into wastewater resource recovery facilities. This means moving beyond pollution control to resource valorization, and is fully aligned with the EU's 2050 goals, like mentioned Matteo, for climate neutrality, circularity, and competitiveness. To do this, we are deploying green and digital technologies that can help to accelerate the recovery of water, energy, and valuable resources, both from the water and from the sludge. One of the core concepts of Resurgence is the use of seeds of hubs for circularity. These seeds for circularity are strategic tools to initiate future hubs for circularity, which are industrial ecosystems that enable industrial symbiosis and also industrial urban collaboration. And through collaboration across sectors and territories, these hubs aim to enable the digital and green transition of EU industries. To implement this concept, Resurgence methodology is developed in 4 main interrelated stages. The first stage is the R&D of innovative technologies at lab scale, including water treatment technologies and digital tools development. The second stage is the integration of technologies, design, construction, and validation of the pilot plants in the 3 industrial case studies. And the third stage is the promotion of the seeds for circularity, which includes the industrial urban symbiosis case study based in Spain. And the last stage is the maximization of replicability and the scalability. Now let me walk you through the core technologies, technological innovations we are implementing in Resurgence, grouped into 4 main parts. The first one is for technologies for water recovery, including using reverse and direct osmosis with biomimetic membranes, developing nanostructured membranes for membrane distillation, and we are also using nanostructured materials for advanced electrical chemical technologies for water recovery. Through these approaches, we aim to recycle over 20,000 cubic meters of industrial wastewater back into the process. And secondly, energy integration is also an important part in our approach. we address energy recovery and optimization through salinity gradient, energy recovery using technologies, electrochemical technologies, reverse electrodialysis, and capacitive deionization. We also aim to produce biogas with anaerobic membrane reactors and hydrogen production via dark fermentation, complemented with electrolysis. And also we also recover waste heat using a novel rotating heat exchanger to improve the thermal energy reuse. Altogether, we target a 30% net reduction in energy consumption. And the third innovation is focused on the recovery of valuable materials from wastewater and from sludge. Each of our 4 case studies touches a different product stream, which I will explain in more details during the case study introduction. In total, we expect to recover 12 feedstocks, which can be revalorized. Lastly, we are also integrating a suite of advanced digital tools to optimize and support decision-making, which includes models for water management and energy efficiency, innovative sensors, both electrical and soft ones, for real-time monitoring, and a predictive tool and AI-based decision support tool, together with digital twins of wastewater treatment systems, users, and distribution networks. These tools can help fast, accurate predictions and the optimization of the processes. And our decision support tool is expected to reduce utility cost by over 20% by enabling data-driven operation and early alerts. And this is the case studies in our project. Our technologies are being validated in 4 real industrial and urban case studies, so each one serving as a seed for circularity. The first case study is pulp and paper industry, Navigator, based in Portugal. The second one is chemical industry, Organic Kenya, based in Turkey. The third one is steel industry, Celsa, in Poland, Celsa, Poland. And the last one is the urban industrial symbiosis, based in Spain. For each case study, we plan to implement and validate a modular pilot plant with a treating capacity around 1 cubic meter per hour. And with resurgence methodology, the innovative technologies will be transformed from lab scale to TRL6 to achieve their integration with the current treatment in the industries. Here are the figures that show each of the case study individually. The inner circle represents the targets we aim to achieve with a resurgence, and the outer reflects the current state of wastewater management, highlighting areas in need of improvement. For the pulp and paper industry, resurgence solutions will increase water recovery up to 95%. Additionally, the recovery of cellulose and lignin from wastewater and sludge, along with the conversion of the sludge into PHA and biochar, will support the industry's goals of waste minimization. On the energy side, over 75% of heat will be recovered, and biogas production is expected to reach an efficiency of more than 80%. In the chemical industry, resurgence aims to apply membrane technologies to recover materials such as latex and polymers, and to achieve freshwater recovery up to 95%. In the meanwhile, the project will reduce environmental impact by eliminating persistent organic pollutants using advanced oxidation processes. In this case, waste heat and energy will also be recovered. In the steel industry, Resurgence focuses on a combination of membrane processes to recover water and electrochemical or adsorption technologies to recover valuable metals and phosphate from the continuous casting process. Additionally, the sludge will also be valorized. We will do synthesis of metal organic frameworks, MOFs, using sludge from CERSA as a resource. In the urban industrial symbiosis, the treated urban wastewater from local wastewater treatment plants of the south of Spain will be further treated by a combination of advanced tertiary treatments by reverse osmosis or electrodialysis, and energy recovery by reverse electrodialysis to achieve the goal of industrial symbiosis and water circularity. And also we will produce biogas, biomethane, and hydrogen through different processes. 2 qualities of regenerated wastewater will be produced, equivalent to boiler quality, suitable to feed the four industries in the same area, and the electrolyzer quality for hydrogen production in the local oil refinery. And beyond the technical achievement, we are also focusing on impact and sustainability. We are developing exploitation strategies with our partner ENCO, which each partner will identify and develop their most exploitable result with potential exploitation routes, including such as spin-offs, joint ventures, etc. In parallel, a dedicated dissemination and replication strategy is in place to promote scalability of the technologies and engagement with new stakeholders. Here is a table of our exploitable resource or technologies. In summary, the researchers' exploitation pathway is designed to ensure the project results don't just stop at demonstration, but continue to evolve into real-world applications. We planned the 3 phases. In the first phase, we are focusing on sharing results, protecting innovations, and gathering feedbacks from the demonstration. And in the phase 2, the goal is to scaling up the technologies, applying them in new settings, and launching pilot hubs for circularity. And in the third phase, we expect Resurgence innovations to be on the market, supported by the business models, investment plans, and value propositions we are working on now. To conclude, Resurgence, like the other 2 sister projects, is acting as an enabler in transforming industrial water from waste into valuable resources. And we are pleased to collaborate at events like today to help spread the seeds of circularity. And here's some context of our project, including us, Water Europe for dissemination, and ENCO for exploitation. This is our project website, and please feel free to follow us on the social medias. Thank you very much.
Thank you very much, Faye. And so this was in the last presentation of the projects. I said we have 3 projects today, and we saw, I mean, really different perspectives, but all pointing, I mean, at the same ambition, which is increasing the efficiency of water management in the industry and in the different industrial sectors and subsectors. It was interesting, I mean, in the last slides, I mean, about the matter that there is a clear pathway to go up, I mean, up to the commercialization of the products of the project, the Resurgent project, which is, I think, a common ambition of all projects that are participating today at Water Project Europe. And now we start with the panel discussion. Now that we have all introduced ourselves and we might know better one another. I think that it's time, I mean, to discussing, to debating about, I mean, your projects and the synergies that the project can create, I mean, to increase the effectiveness and the impact on the EU society and economy. I don't know, Shafee, do you want me to start?
Yeah, please, Andrea.
Okay, so I mean, you want me to start, I mean, with the first question, then you can continue. Or do you want you to start, I mean, to address the first question to the speakers?
I think you can start to give us an example. Yeah.
Okay, thank you so much. So for sure, I mean, we saw, I mean, this project, 3 projects, and have distinctive objectives. I mean, the Resurgence, Cornerstone, and Revolution have let's say they struggle in the same domain, but they have different objectives. Now, this is a question, I mean, to all of you, and also, I mean, a question that I would like also to address also to Matteo, I mean, in terms of as a keynote speaker. What do you see? I mean, what are the key synergies and the complementarities, I mean, between this project, between Resurgence, Cornerstone, and the Revolution? How these complementarities, how this, I mean, synergy can be used in order to leverage the impact, to maximize the impact of the project at EU level and maybe beyond the EU level. I don't know who wants to start.
Well, if you allow me, yeah. Well, I think even though our projects have different technical focuses, we are working towards the same broader goal, which is to make industry more circular and sustainable. And one thing I've noticed is that despite approaching circularity from different angles, there are clear overlaps. For instance, all 3 projects involve membrane processes for water recovery. Both Resurgence and Cornerstone are exploring electrical technologies for resource recovery as well. Even the specific technology is different. There is a lot of value that we can share and technical insights that we can discuss to strengthen each other's work. As mentioned in the presentation, we are planting the seeds for future hubs for circularity, and these insights from other projects could really help grow the seeds grow by integrating complementary development from the other projects. By combining our experiences, we can create more scalable and interconnected outcomes. That's my perspective.
Thank you, Shafee. Who wants me to continue?
Maybe I can just
very
continue.
much
Okay. But yeah, thank you, Shafee, for this very nice overview of the synergies. And I fully agree that we have a lot of overlap between the different projects. And although we are having different industries involved, it's still like similar process industries. So my hope is also that we can collaborate on this to really also see the bigger picture of the different technologies that we are developing, the different decision support tools, the digital twins. So we have actually a lot of common background that could be nice also to share more information related to this, to enable the bigger picture of the different process streams. And as Andrea was telling, we are also very ambitious, so there will also be some obstacles during the project. So maybe we can learn from each other also on that. Thank you.
Sure. Eric, please.
Yeah, my comment was also really aligned with Shufe and Thekna. We are actually here in terms of similarities. We all have the same target in terms of water, which is 90%. But in terms of solids, everyone is going differently. So that's one of the complementarities that we have, and we can learn from each other in future events and other technical webinars or whatever, because in terms of technologies, in Revolution, we are more focused on membrane-based technologies. And in some of these technologies, we are actually pretty aligned with Cornerstone. We also have nanofiltration, electrodialysis, heat exchanger technologies in Revolution. So it will be interesting to learn from each other how these technologies are resulting. And then, for instance, in terms of solutes, it will also be really interesting to get to know from Resurgence about the critical raw materials that we are, for example, not targeting in Revolution, but they are. So I think that the different technologies that we are exploring and the different solutes that we are targeting, they are really ground to be explored in future steps.
Thank you, Eric. I mean, that's interesting. I mean, the point of the material. So, I mean, the resource recovery, for which I might ask Matteo. I mean, his opinion on this, because it's quite a sensitive issue from the point of view of the materials themselves. I mean, in terms of selection of materials that can be extracted from, for example, from the wastewater or other processes, and then also, I mean, the impact on the capacity of these materials to be, let's say, ready to market or to create a market for these materials.
Well, I believe that all the process industries are facing common challenges in terms of wastewater treatment and reuse, and also the recovery of valuable solids. All these common challenges require cross-sectoral collaboration. This is very important in terms of what you mentioned, Andrea, of what do we do with the materials that we recover. And I believe that some of the materials that we are recovering in some process industry can be a raw material for other process industry, and we can work on the concept on the industrial symbiosis, but also in the concept of the urban industrial symbiosis. So we need to look at the whole picture and to evaluate the flows that we can obtain and how we can integrate it to be a new raw material. I just want to add that in the three projects we are developing and testing solutions for specific challenges of specific process industries, but we need to work on the future replicability of those solutions, on the future replicability, and also in the potential market that these processes can have. Because I know that, for example, in the Revolution project, we are testing a process to achieve the zero liquid discharge in the chemical industry or oil and gas industry, but that process can be replicated in other industries. So I believe that after the technical validation, we need to explore that to guarantee the deployment of the solutions, and that these solutions can achieve a strong and bigger market.
Thank you, Matteo. Thank you. For sure, I mean, the final ambition is having the deployment of the innovation, which also means building, I mean, the market for having the innovation, the results of innovation ready really for the market and be used by the problem owners, from the users. And that was, I mean, quite interesting. I mean, setting the framework now between the three projects. So starting with the synergies, the differentiations, and the complementarities. But now, let me ask you, another question, which is could be connected to what we said, up to now. What did you find? The project started around 6 months ago. They're all projects that are, let's say, pretty young in their life. But I guess that you already identified, the potential challenges that you're going to deal with for each and every project, because you have different industrial environments, different companies, different demo sites, different pilots, to manage. So project by project, how can you share with us, with the colleagues, the challenge that you already have been, dealing with, or you forecast that you will deal, in the coming days, months of the projects?
If you want, I can actually share my view on that. If you want the challenge more grounded at the project level, so during the implementation of the project, this is the challenges that we encounter in these kind of projects of sticking to the time plan and not having delays with construction of the pilots. And now that we are having this third world war, maybe that could become a challenge at project level. But then also when we are looking at the bigger picture and see the continuity of these projects, a challenge that we will find is actually the implementation of all these solutions put together at the full scale level, because this is well, as someone in the chat is already mentioning, these are intensive technologies that require energy consumption, and also these technologies also require high investment. So also that added up to the fact that there is a lack of references of this sort of zero liquid discharge approaches, for instance. That's a challenge that we encounter as technology developers and solution providers, and this is something that we will have to work on during these years. And but actually the good thing about that is that all of us, the three projects, we have this sort of industrial and key players in the partnership. So that's something that we will work during the project.
Thank you, Eric. Any other view from the other colleagues?
I think also from our side, because we want to integrate different technologies, it's also because these technologies is at a different scale. So it's also the challenge in integrating these technologies, so we actually enable full water recycling, energy recovery, and solutes recovery. And also, as was mentioned before in the panel discussion, solutes recovery can be a lot of different things. So it's also really to focus on what kind of solutes is it that we want to recover, and where is it feasible to recover these solutes. So there's also a lot of mapping of the different possibilities that has to take place, and which we started, I think, in all three projects, but will also require more resources. And also that where we really are now is actually we are just in the gap between research and the current state of the industries. So we have to really, and that is why these three projects are also very good, where we both have the industries and the research-based organizations involved. So we minimize this gap, so we actually come out with potential solutions. But yeah, again, we are very ambitious, but we should also be in order for Europe to sustain and improve our water and energy and solutes. There has been a lot of focus on water, but now the solutes and the other resources in the water streams are also at least addressed more. So that is, from my side, really, really a good thing, but it's also a challenge.
It's surely a challenge, one of the challenges. Shafee, any
Yes.
from Resurgence?
Yes, from the technical aspect, I think one of the challenges, the technologies works fantastically at lab scale, so we need to make sure when we scale them up, they have at least similar performance in real industrial environment. This is why at lab scale we at the last stage we use real industrial wastewater from each case study to simulate the real conditions. And another thing is I think is the economic side. Like even if a solution is technically efficient, it's not always easy for end users to adopt it if it costs more than what they are doing today. So it's really important for us to build strong business cases and show the long-term benefits, not just environmental but financials as well. Another challenge that I found is to get people from different backgrounds, engineers, scientists, in industrial partners and policymakers to speak the same language. Sometimes it's complicated to align expectations and make sure that everyone understands the technical and the practical aspects of what we are doing. So I think the communication of reliable and realistic results is very important in this aspect.
Many thanks. Thank you, Shafei. I think that all projects look at, rightly Sena remarked, we are in the middle between the research and the users and the industry. And we really need, to work in order to have our projects be able to have an impact on the capacity of the industry to become more efficient in water management. But now there is always, a point which is about projects, as long as they run and they are funded, they work well, they support, the different initiatives. But what is, in your opinion, it's not only about these 3 projects. This could be is a question that, let's say, covers, a larger view from experts like you, which are used, to run projects and to live in a research and development environment, which points at improving the capacity of the different ecosystems to be more efficient. But this is a question for all the system projects. What should we do in order that results innovation can have an impact beyond the projects? What is, the key actions? What are the key actions that you see are as relevant and necessary in order to have the project result being really deployed, and scaled up to different industrial environments? Who want to take this first challenge?
I can also maybe say something on this. At least this is just from my point of view, and I'm like a researcher, so I'm on the low TRL levels and developing technologies. But I think it's really important actually that we talk together. We talk to the industries, we understand their needs, and the industries also understand the technologies from our point of view. So if we talk together, we have less probability to come out with something that does not fit the industries. So again, to have this mission-driven research where we talk to the industry, see where is it that we need to aim at. We will not reach that during this project, but this is also where the industries come in. They should see an idea in developing these technologies further and help us to move it into practice. And this is where, again, the gap between research and industry is a challenge sometimes. But I think that we talk together and we see, like Sufei, you also mentioned the financials and the economy. And there was also a comment in the chat on the carbon footprint, and that is really challenges for the industries. So we should look into how can we develop technologies for that instead of just developing technologies that are just fancy. Actually, to say that. So really we have this discussion on what is the needs from the industrial sides as well. I think that's important.
So it is about, matchmaking between the needs and the capacity of the research and innovation environment to meet those needs.
Exactly.
Any other inputs on this?
Yeah, well, and just to complement on what Rena said, if you want that the solutions developed in the project they go beyond the project and they get implemented at the sites, I think it's also really important to have established a clear exploitation strategy among the different technology providers, and also in terms of intellectual property protection and how these technologies are operated afterwards the project. Otherwise, these technologies will not be implemented. So I think that this is also a really important thing. Also, and not really important as well is the part that Techna mentioned about focusing your solutions according to the site needs, to the industrial partner needs.
Thank you, Eric. And I don't know if any other input on this issue.
Yeah, just to add one thing up, I agree with Sedna and Eric, and also I think what we are developing in our projects with digital tools, the decision support tool, and also life cycle assessment, both environmentally and economically, can help delivery a language, an image for the industries to see what our technologies can bring, what benefits and or cons that applying our technologies will bring to their water circularity.
Thank you so much. There is also a question, and then I have also another question from one of the participants online. Said that, do you plan to involve startups or scale-ups which perhaps develop similar things to bridge the gap between low TRL research side and high TRL application at industrial side? So the question is, in let's say in the implementation, in the deployment phase, do you also plan to involve startups, or how do you see the involvement of small medium enterprises? In these processes. Any reply to this? It's an opportunity. I think that's sometimes, when you have big companies involved in industrial innovation, then maybe that small medium enterprise might have, that flexibility that might allow them to proactively participate into the process. So this, could be an opportunity to explore. But I have another question, which is still, about the challenge and the opportunities that might be created in order to increase the impact of the results of the project. And one of the challenges that I've seen many times is the matter that industry are a bit reluctant in taking the risk, because of course at the end of the day there is a need for investments. So how much the project might be convincing in the matter that, I mean, and say our results, I mean, are really trustworthy. Our results are really excellent. Our results, I mean, can really solve the problem. Our project can convince, I mean, the industry in retaining the results and accepting the risk. Or do we need incentives for this? Or do we need, I mean, a de-risking system that can allow industries, I mean, to take over the results of project and invest whenever it's possible? I don't know if also, I mean, our keynote Matteo can give us, I mean, some inputs also from the SPI perspective.
Yeah. Well, I believe, and I think that we all agree that we have a gap between the result of a project and implementation. And that is something that all the people that is working in research and innovation projects suffers along his career. The industry, I think that when we show to them, when we can show a good result, a good technical result, they are interested and they are willing to contribute to implement the result. But we need to help them to the industrialization of these solutions. At the end, when we finalize a project at TRL 7 at a limited production capacity, there is still a step further that we need to invest a lot of money to demonstrate that and to implement that. And I believe that we should look for funding solutions to help the industries to invest in these solutions. At the end, we already have some European funding partners that can collaborate to that, but I believe that we need still further support to help the industries to apply these new solutions.
Any other insights or viewpoints, I mean, about this challenge?
Yeah, I really agree also with what you are telling, Matteo, but also to have some funding for the higher TRLs to really implement the technologies. And again, I think it's really important that we talk together. I think that is some of the most important, is that we really see the needs of the industries, and the industry sees how we can also help, maybe not in 1 year, but maybe in 5 years, if they provide data to us, if they help us to develop the technologies. This will also be a way of de-risking, because we need to de-risk these technologies. That's also why in Cornerstone, we only develop the technologies to TRL 6. And if we need to do all the things of water, energy, and other resources in the water streams, it's really complicated. So that is, again, what is the needs of the industries. So we need to de-risk. And I think one of the de-risking strategies is actually what we're doing here. We are collaborating with industries, we are collaborating with universities, research organizations in these projects. This is also a way of de-risking. And then there will come hopefully some additional funding that can further scale up the processes. But again, what we're doing here and what we're also doing today with the sister projects is that we talk to each other. So really understanding the needs of each other. I think that's important. And then the decision support tools, the digital twins, will also help the industries to see the different scenarios, also the life cycle assessments. If we do it in this way, what is the future scenario? Then if we do it in that way, what is the future scenarios? So I think this is also a way that we, within the projects, can de-risk, in my point of view.
That's important. It'd be interesting that you make the matter that you are TRL 6. So then, I mean, let's say it's a long way, I mean, to go beyond that. It's a long way in terms of time, in terms of going, I mean, let's say, I don't say from lab to market, but from lab to at least, I mean, almost ready to market products. So and there is a need for a lot of investment and additional innovation, research and innovation activities. Now, this is quite important. But I mean, this is a common concern, and I think that all projects struggle, I mean, in finding, I mean, their way towards, I mean, the having, I mean, the impact and providing, I mean, what I mean, the reason for which we are investing money in research innovation activities is to have results. Then, of course, there is also another viewpoint, which is very my personal viewpoint, the matter that when we start at low TRL, when everything goes well, I mean, that it means that the process is a positive process, that there are no too many bottlenecks and we are arriving to excellent results. But anyway, I mean, this really takes a long time. So I mean, 8 to 10 years is unnecessary to start from a very low TRL up to the market uptake. And I have another question and from one of the participants, say perhaps collaborating with water standardship initiatives like the AWS, which we are collaborating as well as Water Europe, or other highly industry involved association like GWI, which is also we collaborate also with them, will help to bridge the results for these 3 projects to more corporates in the same sector and other industrial sectors as well, more dissemination opportunities. This is true. If I can add on this, I can also reply that we are Water Europe, we collaborate with AWS, we collaborate with GWI, and of course, I mean, our efforts in terms of dissemination will be in the clustering perspective, not only from the researcher's point of view, is, you know, I mean, to bring the results of this project to the companies, to the industry, to the users, you know, that can be at least visible and can be seen, I mean, from a large pool of potential users. This for sure is our commitment. I don't know if there is any other comments, I mean, to this panel that was, I mean, very much interesting and really, I mean, a kickoff of collaboration between the projects. If there is no other question or issue to debate, I mean, we can start. We have a Mentimeter, and this Mentimeter, it is addressed not only to the speakers, but to all the audience, in order that we can get some insights also from who participated, not from the project side, but from the spectator point of view. So we start with this Mentimeter. Let me use my mobile, that I can also participate. Let's wait for a few seconds that participants can join the Mentimeter. People are joining. Let's wait for a few more seconds. I think that we can start with the first question. So this is, say, it's not a trivial question because it gives us, I mean, the opportunity of creating a cloud of opinions. So what is the first word or concept that comes to your mind when thinking about circular innovation in Europe? It's the first concept. contributions are coming. So it seems that technology, along with reuse, collaboration, and investments, as well as resource efficiency, represent, the main common understanding of most of us. But I also see what the energy nexus, industrial symbiosis, technologies, again, waste reduction, resource recovery, and reuse of water. I also see it tricky, which is interesting. It's tricky. Thank you for contributing. I think that we can go to the next slide. The next slide, there is a multiple choice with a single answer. So the question is, which area do you believe is currently the biggest barrier to scaling circularity solution across Europe? So we have the majority think that there is not enough collaboration across sectors, which is also understandable because as much as the water sector is fragmented, also the users are fragmented. Followed by, no, sorry, the most important is lack of funding and financing. So once again, the issue of, I guess also investment, represents the main barrier to scaling up solutions, followed up by insufficient collaboration and lack of policy coherence. Because also from the policy side, well, I don't say that, yeah, in a kind of jungle, but it's not that easy, to manage the different policy approaches and framework, particularly from different interpretation and implementation by the member states. I think that we can go to the next one. It's also interesting that technology gaps were not, that more popular. So it means that from the point of view of technology, we are in a good status. Now, the next one is a ranking question. You should rank the following statements in order of importance for driving systemic circularity in your specific sector. So what do you need more? You can rank, the sixth statement, from 1 to 6. There's an interesting fighting between policy and investments. As we can see, still investments represent the most important driver for systemic circularity in Europe, followed by stronger regulatory frameworks, which is another important need. Then we have cross-sectoral collaboration, market uptake of innovative solutions, skills and education, and digital data infrastructure. So strange that digital goes at the last position. About skills and education, I would like, just to spend a few words about the matter that skills education represent an important challenge, and also an important, very important goal in the water resilience strategy, because there is the need for being more effective in refining and building new professionals, because we are in the need. As long as technologies go ahead, then its deployment requires people to be educated and skilled in order to be able to manage also the innovation. Now you can see that on top, investment represents, the main driver for circularity in Europe. Can you go to the next one, which is also the last? So this one sentence is an open question. What is one action that the European Union should take to boost the uptake of circular solution? In one sentence, or in one word. I ask my colleague to scroll up and down the different inputs so that we can see them. Because you see that financial support and incentives represent the majority of the actions. And also legislation, it's an important issue. So regulations and funding, and I like this twin system for expressing the need. Simulation of project results also, which is of course is important, to better adopt solutions. And with the last one, industry to adopt circular model business and provide funding. So I mean, I see that on top funding, say finance, remains, I mean, the most important issue. As we said, I mean, in the transition from lab to market, investment are essential, and also understanding that industries should be put in the situation of taking the risk with some support when things, I mean, don't go, I mean, in the right way. But nevertheless, what I see is that there is the need for an European mechanism for really supporting the circular transition through the legislation and through financial tools. That, by the way, is something that is also coming up in the initial discussion about the next MFF, for which I see that there are already discussions about how to integrate research and innovation funds with I mean, funds that can support the transition to market, and also by integrating different kind of funding from European to national level. So as you can see here, funding 13 responses, incentive 3 responses, which then can be put together. So policy 3 responses, and another one about centralized database, or example of good, I think, case studies. So I think that was also a meaningful Mentimeter, which is aligned, I mean, to the discussion that we had today in this Water Project Europe. And I think that after this, we can wrap up this interesting event of today, which also, I mean, gave the opportunity for the project to start shaking hands and collaborating to the possible extent, I mean, in order to create the synergies and increase the impact of each single project. I would like also to highlight that the project will meet again online on the 28th of July, because there is another project of the same series, which is the Highways, which is a project which looks at energy, water, resource recovery that started with Horizon 2020, but it is an Aspire project, which is going to end. I mean, it's an outstanding project with a lot of inputs, a lot of results, and the 3 projects will be hosted for a session during the final conference of the Highways project that will take place in Brunel in the United Kingdom next 28th of July, and we'll send out, I mean, additional information on how to join these events that can be joined in presence or remotely. But once again, we're going to have the 3 projects speaking there and highlighting, I mean, their connection capacity of addressing the challenges in their respective sectors. I don't know if there is any of you who wants, I mean, to wrap up and to say, I mean, some final words. I mean, I would invite, I mean, Shui Fei to do this, I mean, as leader of the research projects.
Thank you, Andrea, for moderating the panel discussion and the Mentimeter, which has been inspiring. And I think today we have set a foundation of our future collaboration within the 3 sister projects. And like today, we have shared our insights and the challenges that we met during the implementation of the projects, that I think is very helpful for us and to make a more efficient progress of our projects. So I'm really looking forward to the next clustering event between the 3 sister projects, perhaps in person. That would be fantastic. And thank you very much again.
Thank you so much. I'd like also to confirm that we are also working for having an in-presence clustering event of the 3 projects. Will be, of course, I mean, of course, a different shape, a different framework. likely to happen by the end of this year. And but there are, I mean, news, I mean, to be shared before that. But we can start, let's say, stimulating the interest also of the audience in participating in these new events, in which, for sure, I mean, demo case pilots will be also able, I mean, to speak and to showcase, I mean, their experience after around 1 year of work by the project. So, if I may, if there is any other things, I mean, to mention now. I would like really to heartfully thank all of you for your contribution. It's really, I mean, it's the foundation for starting collaborating between the 3 projects and beyond that, because we have also other projects that we might involve in this process. And many thanks also to our keynote speaker. Many thanks to my colleagues, Ioanna Prisana, Alessandro Argo, Anais Balada, and Isabella Gervasio for having supported this event. And well, I mean, see you in July at the IOA's final conference with some of you, and all the best. And thank you so much once again. Thank you. Bye for now.
Thank you. Bye.
Thank you. Bye.
Bye bye.